Today's video is demonstrating the proper pre-use check of the INO Max DS-IR nitric delivery system. It is based on manufacturer standard guidelines, and it ensures that the system is ready for patient delivery with any of the various reach ventilators and circuits. We will break it down into sections, and we will start with scratch with showing you all of the pieces and items necessary to do the pre-use check. Let's start from scratch and identify all of the parts that are needed to perform this pre-use check. You will need an oxygen source capable of a high pressure as well as flow meter. You will need the nitric test tank. You will need the high pressure regulator with black transport cap and cables, the main nitric DS unit, the nitric DS blender, and you will need one delivery tube, one piece of oxygen tubing, one sample line, the gray electric cables, an injector module, the blue corrugated tubing. You will need either a gray tube adapter, or you can use a 5mm ET tube adapter if necessary, one 15mm adapter, and a sample tee. And those are your pieces. This section is initial connections. We are going to put all of the components together, starting with the nitric high pressure regulator. And very important that we inspect the white cap, that there's no cracks or chips before we apply. So we will apply the regulator properly to the test tank in this case, and hand tight as best you can. Okay. Then the next component is the black transport assembly cap with the infrared cable. In placing the cap, you want the infrared cable to line up with the tank regulator. There's something called an I button. So the cable should line up and the black cap will slide on correctly. Then we will take the infrared cable and the nitric delivery lines and connect them to the back of the main unit. So the infrared cable has a red dot, which lines up to the red dot under the port labeled IR for infrared. The delivery line can go in either port. There are 3 ports. It can go into either the first or the second one. That connects the regulator to the back. Next, we will connect the blender to the main DS unit, which goes on the port somewhat next to the infrared. And then slide your white cap over. One piece to make sure is in place before you start is your water separator cartridge. And it snaps in over here by the water trap. And that's the back. So I will turn the units around. We are going to then connect the blender high pressure oxygen hose to our oxygen source. And then 2 more things on the front. The nitric delivery tubing goes into that port. And your electric cable, both ends are identical. Either end, find your red dot and line it up on the front into its port. And that is the initial connections. At this point, what we're going to do is turn on the unit. We are going to check the splash screen, make sure the screen's working, and we are going to listen for the speaker check. You need to hear the audible tones to ensure that your speaker is working. So we will turn on the unit on the back left side, and our screen will come up and wait for your speaker check. And then there's one more thing to show you on the screen. Maybe it takes 45 seconds. Okay, there's your speaker check. Then one thing to notice on the front of the screen over to the right of the unit will give you a graphic of an INOmax cylinder. That is telling us that it is communicating with our tank. And then we will move into the next section, which is the high pressure leak check. This section is pretty quick. It is the high pressure test. So we're basically testing to make sure the system is tight with no leaks. In order to do that, now that everything is connected, we are going to crack or open the cylinder and then close tightly. And 30 seconds is sufficient, but you want to observe your pressure gauge for any signs of a leak, any needle falling. It should stay completely tight and not move. If you experience a leak or a decrease in your pressure, your troubleshooting points would be ensure that there is no leak around the regulator, it is on tight, ensure your water separator cartridge and water trap are properly in place, ensure that your backup switch on the front of the DS unit is in the off position, and ensure that your blender flow meter is off. Those would cause leaks. So if all of those are good and your system's tight, your pressure holds, it's a pass. And if you did experience a leak and you checked all those, turn it off, turn it on again, start over. If it still fails, you want to check your operator's manual for other troubleshooting. This section is demonstrating the low range calibration. It takes approximately 3 minutes, so we'll get it started and then talk a little bit about it and wait for pass or fail. So up in the unit's left, right, up in the top corner over here, we are going to select the menu button. Down on the lower corner to the machine's right, I guess it would be, we pick the low-cal, and then over here in the middle of the screen on the side, we are going to select the flashing low-cal icon, which has initiated the low-range cal. This requires no calibration gases, and it's low-range calibrating the 3 cells: your oxygen concentration, oxygen percentage, your NO2 cell, which measures nitrogen dioxide, and then our NO, our nitric oxide cell. A pass at the end of the 3 minutes will result in the 3 bar graphs turning green and a single tone will be heard. If for some reason any of the cells fail the low range cal, you will get a red bar. In that case, we're supposed to re-perform the entire low range cal in hopes to correct the failure. If not, take the unit out of service, refer to the operator's manual, and call for tech support. The tone and the 3 green bars is a successful low-range calibration. We are done with that piece. We will move on to the next section, which is the purge and alarm test. Okay, in this section, we are going to demonstrate the purge and alarm test. So we will need to build the test circuit. We are going to start with the injector module and note the arrow. That is the direction of flow to the patient. We are going to connect our blue corrugated tubing onto the end going towards the patient. and a 15mm adapter in the other opening of the injector module, and your nitric tubing adapter or 5 or 5.5 ET tube adapter if you don't have one of these. Standard oxygen tubing goes on to that adapter. We have our sample T, which is going to go on the, we'll call it the patient end. And sample line connects to the sample T and to the sample port on the main DS unit. And then we must connect the cables of the DS unit to the injector module. So the cable, there's a red dot that must line up with the red dot on the injector module itself. The other is the nitric delivery tubing, and it has its own little port there on the injector module. The last piece is connect your O2 tubing to an 100% oxygen source flow meter. That is the circuit setup. Now we are going to perform the purge and alarm. We are looking for 3 alarms in this. We're going to see a cylinder off alarm, a low NO, NO2 pressure alarm, and then the last one that you will see is your set nitric dose is 0, open your cylinder valve. That's an alarm. So step number 1 is you need oxygen to flow first. So we are going to set our oxygen source to 10 liters a minute. We are going to check and ensure that the cylinder, the test nitric cylinder, is off but pressurized. Then we are going to come down to the DS unit and set our nitric parts per million to 40. We'll immediately get an alarm, hit silence, and that is your cylinder valve closed alarm telling you that your cylinder is closed. Now what's going to happen is your NO2 measurement, the middle value is going to start to go up, and then as the cylinder drains and depressurizes, it will drop to 0. And we should get a low NO and NO2 pressure alarm once the cylinder drains. There it is. So low NO, NO2 pressure alarm. At this point, we open our cylinder on, and we are going to drop the nitric dose to 0, and we should get a cylinder closed alarm and your set dose is 0, open your cylinder valve alarm is what you will see. And that completes the purge and alarm system test. In this segment, we are going to demonstrate the complete performance test. The purpose of this test is to verify your 3 cells, oxygen, NO2, and NO cell, and make sure they are within range and properly calibrated. So for this test, we need the same test circuit that we use for the purge and alarm test. We are going to start with oxygen flow at 10 liters a minute. Okay, so 10 liters a minute going. Cylinder needs to be on. And then we are going to set our nitric dose per million, parts per million to 40. The rest of it is to observe those 3 values. It may take a minute or 2 to stabilize. The oxygen value should be 95% plus or minus 3. The NO2 needs to be less than 1.5 parts per million. And your NO should be reading anywhere between 35 and 45 parts per million. If for some reason any of those cells or those values are out of range, the first step would be to do a high calibration on the cell that is not within range. Then if that did not fix the problem, you would change the injector module and rerun the performance test. If it was still out of range, you need to take the unit out of service and call tech support. And that completes the test. Okay, so now that we have completed the pre-use test, which will go much smoother once you complete the whole thing from beginning to end in one flow, we need to point out a couple things. So at the end of your pre-use check, you are ready for immediate delivery for patient care. So as long as you are within 10 minutes of the pre-use check, you can apply to the patient immediately. If you are going to go beyond 10 minutes, what you want to do is close your cylinder and depressurize the system by removing your NO line and pushing on the little purge button right below your infrared line. That will completely empty and depressurize your cylinder. So within 10 minutes, you can go ahead and use keep pressurized and apply to patient. Greater than 10 minutes, turn it off, purge your system. If you go longer than 12 hours from your last pre-use test, you must re-perform the entire pre-use test before applying to a patient. So every 12 hours, this has to be done. And that completes the pre-use process.